Hey guys, welcome to another session on maths for data sciences. So in our previous session, we had studied some properties for a normal distribution. So we looked at how the shape of the distribution is a bell-shaped distribution, as can be seen from the given PDF here. Then we saw that one of the major property of a normal distribution is that it is symmetric about its center point, that is this particular point, and this is also the mean of the distribution as well as equal to the median and mode of the distribution. So clearly, as the value of the PDF is peaking at this point, therefore it has to be mode, since the maximum probability is obtained at this x value, and since this is symmetric about the center, therefore it has to be median as well, because there are 50% of the values on the right side of this x value and 50% on the left side of this x value. And since again this is symmetric about the center, the mean has to be equal to the same median value here. Now since there is only one peak here, this is a case of a unimodal distribution, that is there is only one mode value for this kind of a distribution. Then we looked at how the tails of the distribution here are asymptotic to the x-axis. So by asymptotic to the x-axis, which we mean that it stretches to infinity but it never touches the x-axis. So it will remain very close to the x-axis but never touch the x-axis. So this is how we define the asymptotic relationship with a particular axis. Then we also looked at the PDF of a normal distribution. It is given as 1 upon root 2 pi into sigma multiplied by exponent of minus x minus mu whole square upon 2 sigma square. And then we also looked at some of the metrics that are used to define the shape of the distribution. So since this is symmetric about the center, and we saw that skewness is a measure of symmetry, therefore the skewness of a normal distribution is 0. And for kurtosis, which gives the relation between the tailedness and peakedness of a distribution, the kurtosis of a normal distribution is 3, and therefore it is also called a mesokurtic distribution. Now since the kurtosis is 3, the excess kurtosis, which is computed as kurtosis minus 3, and therefore the excess kurtosis for a normal distribution is 0. Then we looked at how we can calculate the probabilities for a normal distribution. What we do is we basically convert the distribution value, that is, for example, in this case x is a normal distributed variable. We converted the x values into z values using the z scores, and those were computed as x minus mu divided by sigma, where mu is the mean and sigma is the standard deviation of the distribution. So we are just subtracting the mean from the raw x value and dividing the difference with the standard deviation to obtain the z score. Once we have done that, we have a form of a probability, which is pz equal to some z1 value, let us say. What we do is this can be written as phi z1, and we can obtain this particular value directly from something called a standard normal tables, using which we can get the required probability. So we looked at an example in our previous session on how to get this probability. Then we also looked at something called an empirical rule of normal distribution, where there are some 3 standard rules, and the rule states that the probability that the normal distribution lies within one standard deviation from the mean, that is between mu minus sigma and mu plus sigma, the value, the probability that x lies in this particular range is given as 0.68. And similarly, the probability that it lies within the range mu minus 2 sigma and mu plus 2 sigma is the probability value is given as 0.95. And similarly, for 3 standard deviations, it is given as 0.997. Now, why I have written it as a z? So basically, if we convert the mu minus sigma into a z score, how we do that? So z equal to mu, let us say we are doing it for mu minus sigma. So we are calculating the z value for mu minus sigma. It is mu minus sigma minus mu upon sigma, which becomes minus 1. Therefore, we are writing the expression here as pz from -1 to 1 is given as 0.68. So z-score, another interpretation of z-score is nothing but it is the total number of standard deviations that the raw value x is away from its mean value. That is another way to look at the z-scores for a raw x variable. Now moving ahead, we would be looking at a couple of more examples in this particular session on normal distributions. So the question here is that we have to arrange the following in ascending order. So for that we just have to compute the various probabilities. Now the first part here is what is the z-score of a normal random distribution x which has a mean of 20 and standard deviation of 5 for x value equal to 27.5. So we know that z-score can be computed as x minus mu upon sigma. Therefore, we get it as 27.5 minus 20 divided by 5, which comes out to be 1.5. So we can write the final value to the left of this serial number. It is 1.5. Now mean of a standard normal distribution, we already saw a standard normal distribution has a mean of 0 and a standard deviation of 1. Therefore, this value will be 0 here. Now, percentage of data above 2 standard deviations above the mean. So, what we are calculating here is, so this is part 3. The percentage of data, so percentage of data above 2 standard deviations above the mean, which is pz greater than 2. This is because if we compute the z-score for mu plus 2 sigma, this will be computed as mu plus 2 sigma minus mu whole upon sigma, which comes out to be 2. Now, how to get this particular probability without using the standard normal tables? So, how we do that? Let us say we take a normal distribution and this is the center. Let us say this is equal to z equal to 0. So, for a standard normal distribution, the mean is 0. Therefore, we can write this as z equal to 0 here. Now, let us say we put minus 2 here and plus 2 here. Now, since the distribution is symmetric about the mean, we know that p z less than minus 2 should be equal to p z greater than 2. Also, from the empirical rule of normal distribution, we know that 95% of the values lies within 2 standard deviations of the mean. Therefore, p minus 2 to 2 should be given as 0.95. This is the second empirical rule of normal distribution. Now, since the sum of all these 3 probabilities, so this is 1 and this whole thing is 2 from here till here, and this is 3. So the sum of all probabilities is always equal to 1. Therefore, pz less than minus 2 equal plus pz greater than 2 plus p minus 2z2 equal to 1. Now this is equal to 0.95 and this is equal to pz greater than 2 because we saw that due to symmetry pz less than minus 2 should be equal to pz greater than 2. Therefore, we are left with 2pz greater than 2 equal to 1 minus 0.95, which is 0.05. Therefore, pz greater than 2 is given as 0.025. So, we can write the percentage here as 0.025 or 2.5%. Then, we have to calculate percentage of data that lies below 1 standard deviation above mean. So, what we need to calculate here is nothing but let us try to look at it here. What we are trying to calculate is p z less than mu plus sigma. And since we are converting it into z-scores, this becomes p z less than 1. Now, just like we saw in our third example here, we were able to calculate p z greater than 2 as 1 minus 0.95 divided by 2. We can easily calculate p z greater than 1 using the first empirical rule as 1 minus 0.68 divided by 2, because there are 68% of the values which lies within 1 standard deviation of the mean. Therefore, there are 16% of the values, so that is 0.16, which lies outside one standard deviation of the mean on either side of the mean. So if we have a normal distribution and we have -1 here and +1 here, and this is 0. So the total percentage, this we already know from empirical rule as 0.68. Now since this and this has to be equal, therefore it has to be equal to 1 minus 0.68 upon 2, which is 0.16. Now it is very easy to get our initial probability. So p z less than 1 is nothing but 1 minus p z greater than 1, which is equal to 1 minus 0.16, which is 0.84. So we can write the final value here as 0.84. So this is how we get the probabilities using empirical rules. So note that we are not really using the tables here. We are simply using the empirical rule to get our required probabilities. Now in our fifth part, we are to calculate the percentage of data that lies one standard deviation below the mean. So percentage of data below one standard deviation below the mean. So this means what we are calculating here is p z less than -1. Now we already calculated in our fourth part p z greater than 1 as 0.16. Therefore, due to symmetry about z equal to 0, p z less than -1 should be equal to p z greater than 1. Therefore, it is equal to 0.16. Thus, we can write this value as 0.16. Next, we have to calculate what is the probability that the normal random variable lies between mu minus 2 sigma and mu plus sigma. Now, if we convert these variables into z scores, what we get is p mu minus 2 sigma minus mu upon sigma z. So we are converting into z scores. This is mu plus sigma minus mu upon sigma, and we get p minus 2 to z less than 1, which is p z less than 1 minus p z less than -2. This we already know is equal to, so this we calculated in our question 4. This was equal to 0.84, and this also we looked at in question 3. So what we looked at was, actually in question 3 we had p z less greater than 2 as 0.025. Now due to symmetry about z equal to 0, p z less than -2 should be equal to p z greater than 2. Therefore both have to be equal to 0.025. Therefore this becomes 0.025. Now we can subtract this to get 0.815. So this is the required probability in question 6. Now that we have got the 6 values, we can easily arrange them in the required ascending order. So this exercise was basically aimed to see how we can use the empirical distribution to get the probabilities, and we have not used any tables here to get the same probabilities. Now the next part here is the distribution of marks in an exam follows a normal distribution with a mean of 87.2 and a standard deviation of 2.8. Find the approximate percentage of students scoring above 92.8. So we have to calculate px 92.8. Now once again we convert it into z score. So we have pz greater than 92.8 minus mu upon sigma, which is pz greater than 92.8 minus 87.2 upon 2.8. This becomes pz greater than 2, which we already computed in our previous question here. Pz greater than 2 was 0.025, which was also equal to pz less than -2 due to symmetry. Therefore 0.025 is the required probability here, and since we had to give it in percentage terms, this becomes 2.5%. So this is the required percentage here. So once again, this was another example where we use the empirical rule directly instead of using the standard normal tables to get the required probability.